So I just want to welcome you to this session. This is actually on a new defense against network attacks. My name is Pete Diffley. I'm the Senior Manager for Global Partnerships. But I'd like for you to welcome very warmly, it's Ian Schmertzler, and he's actually the founder and president with a company called Dispel that are actually based in Austin, Texas. So a similar southern accent as I have when you hear it. So I'd just like to welcome you, and nice round of applause. Thank you.
Thank you very much. Hello, everyone. So I do not have a southern accent unless I put on my Georgia Tech hat, which has been a long time ago. So hello. First, I'd like to do a poll, which is going to be a little bit difficult with these lights, but it will help me set how I talk about everything here. How many of you, just raise your hands, are executives within your organizations? Okay. And how many of you are operators? Let's put that down as folks who are in the field touching these things every day. Okay. And I know that some of you are raising your hands multiple times. That's okay. Third question is, how many of you have a titled role of Director of Operation Technology or working within that organization? Wow, we've got a diverse crowd here. IT? Anyone just covering IT? Okay. And then, is there anyone in here whose title involves cybersecurity? Namely, are you the CISO? We've got one. All right. 2, 3. Fine. Well, thank you for that. So why we are here today? This is all about uptime, availability, and safety. If it wasn't, you would not be using trihedral. What about cyber? It's not on that list. And the basic reason for that is OT prints money, IT spends money. That was told to me by a very wise gentleman as he was throwing things at us. The mission that we always have to keep our eyes on is within the limits defined by money, people, and nature. You've got to maximize those 3 things. And otherwise, you need to get out of the building. So what everyone in this room had was loads of sensor data, increasingly more of it as we got better at our sensor systems, and plenty of analytics tools that could tell you when something was going wrong. What everyone wanted was to have the ability to act on that data, and that's when companies like Trihedral appeared. And what that required previously to software was doing one of 3 things. You called someone on site, you sent in a specialist, or then you did remote access into the systems. And that last piece is the part that's important for us in this room today, because then came cyber. I mean, remember the days when you used to buy computers for home use and you didn't have a login? That stopped being possible. And as a result, uptime, availability, and safety, which had all been going up because we were having more and more software in our lives, started to go down. So the main thing was that remote access went from being something where you just pressed a button and it happened to being a 5 to 15-minute login experience. I don't know how many of you are having that miserable experience right now, but I presume if you guys really care about cyber, this is starting to happen. So why did this happen? And that brings us to the topic of today. For lack of an alternative option, cybersecurity has become an exercise in building castles. And as time and money allow, you add additional walls and you improve the ones you already have. This strategy is called static defense. It fell out of fashion in the physical world about 100 years ago. But that's because castles don't move and they're really easy to find. So unless you are constantly and correctly anticipating the type of attack that will be launched against you, someone will find you, analyze you, work the problem, and punch a hole through. So the solution in the physical world was to stop building castles for everything. Instead, you use it when you absolutely have to. And instead, start taking the things you actually care a lot about and putting them into vehicles and moving them around. Now, that strategy is called moving target defense, a classic tactical implementation of which would be a submarine. And starting in the early 2000s, people began to implement moving target defenses into their digital lives. So in 2001, this started to appear on processors and in memory. And in 2008, moving target defense began to appear, at least to the best of my knowledge, out in the world of networking. So static defense in brief, I realize that I just said that that's the pre-existing strategy that's starting to fall out of date, but given Everyone in this room needs to be aware of it, and this is supposed to be a training class. I thought I'd take you through what you do with static defense. So step one, for the systems integrators in this room, you already know all about this. You do a risk assessment. Think of that as the idea of you're doing a wall design. And that tends to involve 4 things. First thing you need to do is you need to do an asset inventory. Second thing you need to do is you need to do a network mapping. So those things are actually related. What you're doing is you're saying, what the heck is actually in my system? And it is at that juncture in life where you realize that that box over there with the light blinking is actually rather critical. And that happens usually when the IT person comes over and says, this happened before I was in high school. I'm unplugging this. And someone else says, don't you dare do that. After having done an asset inventory and a network mapping, then what you need to do is you need to identify every one of these darn devices, and then you start looking around to see what their versions are and whether there are patches available, and you start creating your map. After you've done that, you also create a set of implications, which are, namely, if I don't patch this thing, what's the worst possible thing that could happen to me? Now, there are lots of people out there that will advocate that they are the people that know how to do this. Frankly, most of them tend to involve you guys so much that you're better off doing a lot of this stuff, at least initially, on your own. But after you've done that, you need to throw warm bodies at this problem. The prices I've seen for doing this properly, done not right, it's below $100,000. I've usually seen it around $250, and that's a lot of money. The alternative is for $29.99, you can buy this book and read this book, or throw someone at this. And they're going to get you an awfully long distance there if you aren't doing anything yet. The second is risk remediation. Think about that as wall building. And this is when you need to start implementing the patches, which means you need to schedule when you're going to take systems offline so you can install them. This is a time when you realize you let that platinum package lapse on that certain PLC. And then you need to batten down the hatches. So that is unplugging the extraneous wires that lead to nowhere, or that hotspot that really shouldn't be there, all that sort of thing. Then you need to start doing network segmentation. For the people who do not deal with networks every day, what this means is if I've got a PLC over here, I want the only way to access that PLC to be to go through one particular network which doesn't access anything else. It's that simple. And then you start doing defense in depth, which is a euphemism for, 1, you're going to be spending a lot of money, but 2, you're going to start layering more and more defenses in, because some of the boxes out there, you can't put a password on them. You just can't. So you're going to need to put some stuff in front of it. Now, again, this will cost a lot of money and it will take a lot of bodies. It is a good idea. Before you go out and hire anyone to do that, this will take you 2 months worth of weekends to read, but by the time you're done with it, no one will ever pull a fast one on you again when it comes to computer networking, and that's kind of fundamental in life. It's also a really good book. Then there comes self-testing. I am not going to recommend any books for this, because that means I'm recommending stuff that will encourage you to poke around, but this is the patrols. These are the pen tests that cost you $25,000. Do not hire someone just because they've done really good pen tests in the IT world. If they have not done OT pen testing, they have a very different conception of what is an actual problem. And then you repeat every year. This is when you go back and you realize, oh, someone bought another product that I didn't hear about, and it's now in the system. This process takes a lot of time. Are you safer as a result? Yes, absolutely. However, because you're doing this over and over again, in addition to costing a lot of money, what did that do to your system? Let's look at what happens typically in remote access. So we're going to pretend for a minute that the asset cluster on the right is your SCADA system. Okay, the operator's on the left. He is not at work. He's someplace else, and he's realized there's a problem, and he's got to get in. So this is the day in the life for Connecticut Water, Maine Water, Las Vegas Water before we showed up. Before they implemented moving target defense. First thing that happens is they VPN'd onto the corporate network. Why? Because the corporate network was the one thing the IT guy, who was labeled as being the cybersecurity person too, had at his disposal, and it had some defenses on it. Then, having VPN'd onto that, he then goes to a jump host. Are there any nodding heads in here? Yeah, we've been through that. Then you go through another jump host. Then you do an RDP connection down to the asset cluster, and Bob's your uncle. The problem with that is while it looks really elegant for a network person, that takes 5 to 15 minutes to do in practice. On average, with the places I've been, it's usually between 10 and 12 minutes. And imagine having to do that with an iPad and you've got gloves on. No one's happy. And that's what's causing the problem to uptime availability and safety. The other problem is a fundamental cybersecurity problem. This is your world, A and B. And A is trying to talk to B. So the way the cybersecurity world has gone about protecting this is they say, right, well, A and B talk to one another, we're going to encrypt that traffic stream. The problem when you're dealing with OT is that I don't care about that traffic stream. It's probably just sensor data. That's not really important. What I care about is finding A or B, because odds are the castle that was built for them isn't really perfect. And then I can just launch my attack there. And when I'm dealing with operational technology, it doesn't tend to look like this. It tends to look like this. So it is really easy to find the target of value. All that said, if this had been a problem 10 years ago for everybody, we all would have moving target defense now. It's become a problem in the past 2 years for people who are using static VPNs. So if you are using PulseSecure, Fortinet, Palo Alto, F5, or Cisco, first of all, I want to say that those are very good people. I know some of them. When they find that there is a problem in their system, they issue a patch as quickly as they can and they deploy it. The problem is their customers cannot immediately deploy the patches frequently. Can you imagine going in and saying, I got to turn off the system for 15 minutes? I'm really sorry, in the middle of a shift? People say, no, you can't do that. And the attack route that's being used is, have you ever noticed in newspaper articles how they say a scan of the system showed that there were 15,000 of these particular VPNs all around the world that had yet to be updated? Without telling you how they're doing that, what's going on is people have developed tables of the locations in cyberspace of every one of the darn targets that are out there. So it's not like they're going after you. They're just going to realize that there's a weakness, develop an exploit against it, and hit the entire table to see what sticks. So when you ask yourself, well, why in the world is everyone using static defense still? Think about how many years it took and what it required for people to stop standing in trenches all day slugging it out. It took a tectonic event and the availability of new technology at a relatively economical price for people to start thinking about defense differently. When it came to moving target defense at a network level, this stuff started coming out 12 years ago. And by 2011, it was being publicly described as something that was really useful, in the US at least. By 2018, the Koreans and the Americans were working together. Frequently, these labs tend to do this stuff because they have infinite money to run these sorts of studies. And by this past year, Argonne National Lab was putting out saying that MTD is critically important. For any of you who happen to enjoy or have been required to read many NIST standards, NIST 800-160, Volume 2, describes the need for moving target defenses in depth. So, how does this actually work? Because some of you folks have a body around who wants to just poke around on computers all day, so why not have them build one of these things for you? The basic way this works is you've got Bob on the left and the system he's got access on the right. Well, in a normal routing environment, your traffic is going to go out there. It's going to go by the shortest path possible as defined by other routing systems, by the routers that are located between A and B. And yeah, there are problems with that because everyone is trafficking across the same routers. So then someone in marketing probably two decades ago came to you and said, now, I tell you what we're going to do. We're going to give you private circuits. You're going to pay us an extra fee for that, but you're leasing a line space. MPLS just stands for multi-protocol label switching. The important thing here is this should be really fast, and because it's only you and a handful of other companies on the system, well, as long as all of you have built really good castles, no one's putting a virus in there and nailing you. The reality is that it frequently looks like this. So my recommendation, by the way, is if you do rely upon private circuits or MPLS, call up your telecom providers and ask them to provide you with a certificate representing and warranting that they actually are not sending your data across routers that are also used for normal internet traffic, because they might be doing a protocol break. I was told that, I'd like to thank a person who, unfortunately, his name can't be given to me, but he runs a set of dams in the Midwest, and they've been trying for 3 years to get this fixed, and once they finally pressed for a formal letter, that was when they found out that this was what was happening. So, in any case, back to the topic at hand, normal routing looks like this. What do? You go to a bunch of public cloud providers, and you spin up virtual machines on those cloud providers. Virtual machines are simply leased processing power on a data center somewhere. So what those virtual machines do is they belong just to you. You lock down every port on them, and you tell them, all right, I need you to make a connection between one of your nearest neighbors. So they don't have to know everyone else, they just need to know their nearest neighbors. And what ends up happening is you create this semi-defined route of yours. And then, a little bit later, you've got to go back up there and swap out the locations of those cloud servers. The result is that you do not create a static network profile. So an attacker cannot obtain and then maintain target lock on you. One remark here, it's going to be our safety moment for the day. Risk concentration. In this world, that involves hyperjacking, which means that, yes, you're leasing cloud servers only from Amazon. Yes, Amazon's terrific. If a baddie comes in, though, and finds a way into the thing that is creating those virtual environments for Amazon, they're going to be able to house every one of the virtual machines that Amazon is spinning up. So my recommendation to you is always use more than one cloud provider at any given time. If you want to understand the implications of hyperjacking risk, is anyone here from the Netherlands by any chance? No. Okay, Citrix had a problem with their virtual desktop launch system that caused the government to say absolutely no government employees may remote in for work, which caused lines in the street for people trying to get to their workstations for a week while Citrix worked on creating a patch. That is the concentration risk you're trying to avoid. Got it? Please say yes. Okay, so Glenn told me that I had to talk about what my company does. I thought I was not supposed to, so now I'm going to do that. What does Dispel do? We do rapid, secure, remote access, and that is it. We get employees to their systems in 3 seconds. We get vendors to their systems in about 15 seconds. If you're running AIs, so this would be a Mitsubishi Mel IPC 5000 series or a Rockwell Automation APC series, we provide them with a sustained, resilient link. We give your administrators positive control over what's going on inside of their systems selectively. So what you get to do is you get to say, I'm not going to ever figure out where that electric wall clock is that's chirping out. I'm just going to secure the things that are on my line. And then you give your security officers the opportunity/excuse to upgrade your networks to a moving target defense posture and provide event-level network segmentation. So what we're doing, to take us back to a diagram we've already looked at, is first, we're doing encryption properly. We're using 2 layers of AES-256 with independent 4096-bit keys used for the initial key exchange. And yes, we trade out the keys every 10 minutes or so, just on principle. Second, though, much more importantly from a moving target defense perspective, we add an MTD layer in between A and B, the result of which being that A and B are disassociated from one another. So with Dispel, let's take that 5 to 15-minute login experience for a vendor, and let's show you what it looks like for a vendor with us. So they get thrown a URL, or they know that they need to go to a console. They punch in their username, password. They punch in their multi-factor. We wait, bang, you're in the system. When you're using VTScada, you just see the VTScada profile right there. And for those of you who have an international presence, what this lets you do is it lets you launch your systems out across the entire world. So if you're supporting teams that happen to be, say, in Australia, well, this system will get you out there, and then once you're done doing your job out there, you get to blow the thing up, and you're done. So what's happening in the background is, after we get rid of the hand-wavy bit, everything in purple, we've just built a better mousetrap. Yes, we're doing moving target defense networking, but we're also throwing in the things that you need, like screen recording on the side, logging of everything that's taking place, so that way everyone is blamed for exactly what they did and nothing more. And then we're putting in the proper identity controllers, so if you don't have those, we've got them. If you have Active Directory and want to link in, we do that too. And the result of which is, for one company, I'm also the CFO of Dispel, because when you're a founder, you just start to collect titles because the board won't let you get rid of them. And the result of that is I happen to know the CFO of Connecticut Water through his CISO, and he reports that they had a $980,000 saving in their first year just on employee time that was saved. And if you happen to be in Europe, the Swiss like us a great deal. What I've tried to do here is show some of the water companies and related entities that work in water that we do business with. So in terms of what we work with, we tie into all the clouds so you don't have concentration risk. And now we get back to the topic at hand, which is I hope I have convinced you that you need to go back and you need to start thinking about doing moving target defense. You don't need to do it with us, but you should be doing it somewhere and somehow. The short answer is back to the basic theme of why you exist and what people care about. And then the second thing is you've carried static defense just about as far as it's going to go. If every single major VPN provider got whacked in the same year, you're probably using a tool that is beginning to fade away. And there's another one available. So how now? Short answer is that clean remote access is a little thing. And everyone in this room is defined by getting the little things right. Also, if there ever was a time when remote access was a good idea, given we were watching everything about coronavirus, this is it. So if you need someone to give you the budgetary approval to do something, now's the time. So with that, I will say thank you. If you want to talk to me, I'm still here, but this is my email address. Be happy to talk to you and give you free advice. And that's it. Thank you all very much.
Thank you, Ian. So, ladies and gentlemen, I'd just like to say we're going to do a bit of a Q&A session. Okay, I'll just bring the mic to you, just because sessions are being...
You also have a beard.
Yeah.
Okay.
Good guy.
We can bond here now.
Can you just expand on the VPN, the two-layer AES stuff that you recommend, and maybe elaborate a little bit more on the moving target stuff? Because we're redundant across cloud providers, but for some of the remote access stuff, there are static VPNs, especially from customer sites. And so just wanted to know, just best practices, some of the things that to look at to go from a static to a moving, and, kind of how do you go about, is it just a URL, a DNS name that flickers between different IP addresses to kind of do the moving target stuff, or just looking for a little bit more elaboration on best practices?
Certainly. So the DNS approach was used by a couple of companies 6 years ago, and it ended up not working because they didn't have an effective space and it took too long to update things. And then there were other people who thought that the vision here was you'd launch a cloud server and then you'd tear it down very quickly, and you'd launch another one, and you were using load balancers. The trouble is that makes you look an awful lot like a unique lunatic who's trying to do something. So that itself is a behaviorally identifiable profile. So what you have to do is you've got to have, one, if you're doing this using people, it takes about 4 people working 3 shifts to maintain one network. There will be mistakes, but if you've got 4 people on it over the course of 24 hours, it's relatively okay. That means it's going to cost you some money. The alternative is you write a script, which we hold the patents on having done, so you can automatically launch these networks of virtual machines across different cloud providers and shift them. To be very clear, the VPNs that are between these cloud servers are still a VPN. So if you froze time, you would say, yes, this is static. The key thing here is that they're shifting over a reasonable human amount of time. So a human watches a Netflix video, right? It's a certain profile. You just want to stay inside of that band, and you're not going to trigger an alarm. In terms of the crypto that's getting thrown onto it, if you're working with government, you're probably going to want to strip one of those 2 AES layers off and throw Wolf SSL onto it instead. So that way you've got 2 different libraries in the event that one of them has been compromised. God help us if AES 256 is. The other thing is, in terms of the key size, I like 4096. CNSA says you don't have to go that high for the interim. The last thing I'd say is if you are trying to move yourself immediately to a post-quantum crypto age, for reasons that are largely mathematical, I prefer the super singular isogeny key encapsulation, which is called Psych. And yes, you can download that library. It is free. You can throw that on. Microsoft set it up. They're good people. And yeah, we throw that package in on some things. If you're trying to home roll this whole thing, OpenVPN will let you stash that right into it. All right, I'm
Great
coming
question.
up for air from there.
Okay, anyone else? Must be some questions out there.
Sorry.
So we-
What was that? I did my job right. Everyone gets it.
It's phenomenal.
In terms of wondering how much this sort of thing will cost you versus static defense, I should say this for a minute. VPN aggregators, if you've got big ones, are going to set you back $200,000 a box.
Excellent. Any more questions? I see any hands.
Fellas, I'm the only one with a beard and a suit today, so if you need to talk to someone, you can find me. Feel free to come on over. And thank you all very much for your time.
Thank you.